Hi, welcome to my channel once again. I'm Mr. Delovet. So today I'll be looking at examples on stations. So sit tight and be ready to enjoy the ride. So today I want to look at station. So this is how the questions will look like. With a station, determine the density of, for example, determine the density of an object. You are provided with a metal rule, two wooden blocks, a spherical object, and its balance. By using the blocks and the metal rule, determine the diameter of the spherical object and hence its density. So you have to look at, draw the diagram, write the procedure, observations, inference or calculations, precautions and conclusion. That's what you have to do. So we have to go through each of those stages. So the first thing you want to, before starting the experiments, take note of what you are measuring. What instrument are you using? If you have a meter, it means that you want to measure either the, the length of something. So now we have a meter rule, so the meter and a balance. It means they want us to measure the length and the mass. These are the two important physical quantities that you need to see in your observations: the mass and and length that you want to see in your observation. Because that's the quantity, that's the instrument you have given, and that's the instrument they want to test you on. So take note of that. And so the first thing you have to draw is your diagram. So if I'm drawing my diagram, so you have to take, okay, they'll give you a page and which will have diagram. So now in drawing this diagram, you have to make sure you don't lie. If it has a platform, you place it on a bench, on a slab. You draw the slab like that, and then I have two blocks. This ball was in between. I put that. So the total length was L, and I'm looking for this. You don't need to draw the ruler. Don't draw the ruler across. Make sure you draw, you put what you put there, it should be the measurement, what the quantities you're measuring. So diameter to length, I need to also measure the length here in this. And that's it for your diagram. 2 marks. You don't need to draw the balance. You want to draw, make sure you want to indicate the mass here. You can just come, you can put it at the center and I just make like the width on that. You don't need to draw this and then you're putting the ball there. This is total error. That's an error. So this will be an error. So that's that. Okay, the next thing is the procedure. So let's go to the procedure. So procedure, we're going to go to procedure now. So we look at procedure. So procedure, so in the procedure, you don't need to measure, you don't need to give instructions. So you first start by saying, okay, um, the mass of the ball was measured using blah blah blah, is the balance, and recorded this. Now you go to the next. The ball was then sandwiched between the two wooden blocks. And the total length, blah blah blah, the of total length of the one block to another was measured using the ruler and recorded L. Now the ball was removed, and then the ball was removed, and the length of the individual blocks were measured, L1 and recorded L1 and L2. Now the diameter of the ball was calculated, blah 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 blah. was calculated using by subtracting the total length, was subtracting the length of the both individual wooden blocks, the sum of the sum of the length of the two wooden blocks from the total length that you were calculated in um, the second statement, right? So when you do that, you have to get a diameter, and that's it. That's your procedure. Now, the next thing you also ensure that you go is, how should I get now my observation? What did I observe? The next thing is my observation. Let's go to your observation. Now, observation. Okay, from observation now, from observation, we want to look at now so observation, okay, thank you, good, let's go. Observation, what do we observe? So I'll just use arbitrary values here. What did you see? What did you feel? What did you smell? So we did not feel anything, we did not smell anything, so we saw something. We saw numbers. When we read our meter rule, measure the mass. We saw the mass to be what? Let's say 200 grams. Make sure you maintain the precision of the instrument. We saw the length when we measured L1. We saw L to be, let's say, 21.0 centimeters. We saw L1 to be 10 centimeters. We saw L2 should be 10.0 centimeters. You have to measure the precision, make sure 10.0 centimeters. Now, that's what we saw. Now, if you wanted to make sure that you want to put that my experiment, I repeated my experiment twice. You make sure you have to have L1, you have to L1 prime, L2 prime. So if you same, for example, it's same 10.0 centimeters, 10.0 centimeters, and now I need to see L1 average, which should be L1 plus L1 prime on 2, which is the same as 10.0 centimeters. I should also see L2 average, which will give me L1 plus L2, L2 plus L2 prime on 2, which is have 10.0 centimeters. I should be able to see that. I should be able to see that at the end of the day. So I should see that if you want to say that in your precaution at the end of the day. So if you see this, then it's fine. That's what we saw. That's what you saw there. You saw L1, you saw L2, you saw L, you saw mass because you measured them. That's your observation. This is what I observed. I observed the mass to be this. I observed my length, total length to be this. I saw the length of L1 to be this. I saw the length of L2 to be this. Right? Yes. Now, that's all. The next thing that we go now is our calculations. The next one, because now I said since it does not have qualitative observation, then you will not do inference. The next thing after this one should be what? Calculations. Okay, now let's go to calculations. So calculations. Okay, so calculations. So we have so calculations. We have calculations. So calculation. So we just have, you have to calculate what? You have to calculate diameter, D. So our diameter was total length L minus the L1 plus L2 average. That was it. So you have 21.0 centimeters minus 10.0 centimeters plus 10.0 centimeters. You're going to have 1.0 centimeters. That's your diameter. You also need to calculate a density. So you know density, the formula density is mass over volume. And you knew the mass, but you don't know the volume. So the mass will be same as on 4 on 3 pi radius cube, which is the volume of a sphere. So you have to fill. So you have 3 times 200 grams, which you have inverted over 4 pi times the diameter was 1.0. So radius will be 1.0 on 2 centimeters or what squared. That's where there you have your diameter. Take for example the answer gives it has a value. Let me say let's just say I've not calculated value, but let's just say it has 100 kilogram per cubic meter, or let's say but you know that the value have to give you um, let's say you have to have a value into kilogram per cubic meter. That's what you have. That's all that are going to see. So we have that. So you have the value into kilograms per cubic meter. That's what you're going to see. So you can calculate the value and have whatever you have there. But I'm just using arbitrary values. These are not the exact value you're supposed to have, but I'm just using values from space so that you can really understand. So that's my calculations. I have to calculate diameter, I've calculated. I have to calculate density, I've calculated. So this M stands for the mass, V is the volume, and this one is a volume of a sphere. Then you have to do the substitutions and then you calculate value. Then, what's my precaution? The next thing is my precaution. The next is my precaution. Now, next is precaution. So, precaution. So, your precaution now. Oh, I'm writing. So, your precaution now what I repeated the experiment was repeated twice. Then my answer is correct because they have seen it is evident in my observation. That's fine. Then what's my conclusion now? Conclusion. Conclusion now. So what's my conclusion? So I think you can also guess the conclusion. So my conclusion will be from the experiment, the density of the spherical object was kilogram per cubic meter. That's what you have. And that's it. You have your maximum. So that's it. Very easy, straight to the point. I'll do another examples in a more elaborate way. Again, that will have some inference there so you can see. So check out the next example on stations. Thank you.